Alright, so in this video we're going to be putting together the Enemy Interceptor class. And we shall begin over in the config class where we will need to add a bunch of new configuration parameters that we're going to be using within the enemy.
Alright, so let's load up our configuration, scroll down to the bottom, and let's address these parameters. The first set of parameters will be to describe the enemy itself, and with that we're going to begin with the sprite sheet that enemies will use. Now, as I go parameter by parameter here, I'm very often going to copy existing parameters just to save on the amount that has to be typed. Since, again, this is all very simple stuff, we're just naming some values for use later.
They've only seen this 100 times now.
So since the first thing is a sprite sheet, I'm going to copy the player bullet sprite sheet simply because that is the closest and most convenient sprite sheet from our current position. And we are going to name this field Enemy Sprite Sheet. Now moving over to all of its settings, we're going to begin with the graphical asset that is used, and the asset name here is going to be Enemy. The enemy graphic has 4 tiles in X and 1 tile in Y. It will animate at 15 frames a second, and I want to remove the setting that tells it that it has no damage texture, because enemies are in fact damageable, and we do want to reflect that. Moving on from here, we need to set up the enemy's health, and I'm going to steal the ship health field so that I can change it into enemy health. And enemies are going to have a health value of 20. The next field we need to address are the fire intervals for the enemy ship. There are 2 of them because the enemy's firing mechanism is going to be a burst fire weapon, and we want to have an amount of time that will elapse between individual volleys of burst fire. We also need to configure how fast the burst fires themselves work.
True.
So we'll have a longer interval which controls the overall cycle, and a shorter interval which controls the burst weapon. Both of these are going to be of type double because that is the data type required for fire interval in all of our weapons. And we have this wave fire interval that we used recently on the burst and the wave style weapon. We'll drop that in place and we'll change the name over to enemy.
It's like we're shopping for fields.
Enemy fire interval. Again, this is the longer, or you could say the overall cycle time, which is going to be 1.5 seconds. We can then duplicate that line and change this to enemy burst fire interval. And we'll set that to a much shorter value of 0.15. Alright, next we need to be able to store exactly how many projectiles are going to be part of each burst of fire with enemies. So for this, we're going to have an integer to control the burst fire total for enemies. So let me grab a convenient integer, and that is the original burst total that is used in wave fire weapons. I'll simply copy wave fire total, and we can change the name over to enemy. Let's see, we've got enemy burst fire total, and I will leave this set to a value of 4. Alright, 2 more fields that we'll need will describe the behavior of the enemy. Enemies are going to attempt to avoid the player ship, and they will do this by moving away from it such that they steer around your ship. And they do so by maintaining a calculation of how far away they are from your ship. When they are close enough, they will begin avoiding, and once they begin avoiding, we need to tell them how much they move. Basically, they want to move down the screen and away from the enemy, so we'll give a weight that tells how much they're allowed to move away. These fields are going to be called enemy avoidance radius and enemy avoidance weight. Both of these will be of type float, so I'll steal just really any random parameter that is of type float. And let's begin with the first, which is enemy avoidance radius. And enemy avoidance radius will be set to a value of 300. We can then duplicate this field, and this will be our enemy avoidance weight, and this will be a value of 0.3. Alright, that takes care of the fields that are necessary for describing the enemy itself. Now, enemies are going to have a different style of bullet from players, so we're going to set up a few fields that will describe the enemy bullets, beginning with the sprite sheet that will be used for enemy bullets. I'll grab the player bullet sprite sheet once again, and we'll use this to establish our enemy bullet sheet. And over here in the asset, we're going to be using enemy projectile. Our animation tiles will be 4 in X, 1 in Y. We'll have an animation rate of 15 frames a second, and we will leave the setting of no damage texture. Moving on from here, we also need to establish an amount of damage the bullets will cause and a speed at which the bullets will travel, much like we had done for player bullets. So I'll simply copy these fields, put them in place, and then change the names over to enemy bullet damage and enemy bullet speed. The enemy bullet damage is going to be set to a value of 1. Now this is of course overly low and will make the game very easy. The reason we're going to leave this value low is it aids in testing, because we know in the end the enemy ships need to destroy the player ships, but for testing purposes it is convenient to make our ships very resilient, so we're going to leave the enemy bullet damage low for the time being. The enemy bullets will also have a speed of 4. Now, with all these fields in place, we are ready to turn our attention to the enemy class itself. This enemy is going to be referred to as the Interceptor, so we're going to add a new class called Enemy Interceptor. So for the code file name, Enemy Interceptor, we'll add this in. We'll clean up the sub namespace. We will need to add Microsoft XNA Framework as a using statement. Then down on the enemy interceptor itself, the first thing we need to address is the fact that enemy interceptor extends enemy. Now moving into the enemy interceptor class, there are 2 fields that we will need to maintain as our enemies are running around doing their thing. The first is the enemy's target, and the other is a timer to control firing. The target is simply the game node at which the enemy points its weapon. It is also used as the game node which this enemy tries to avoid. The timer is used to control the overall firing of the weapon. It causes a a repeating call to the enemy's fire.
It's our finger on the enemy's fire button.
Exactly. You can look at it. It's an automated finger which presses the fire trigger for our weapon.
Yep.
So the target is a game node. Field is named target, and the timer is going to be called fire timer. Now we can address the constructor for the enemy interceptor. The public constructor is going to need to take in a sprite sheet simply to satisfy the requirements of, well, all nodes. So our sprite sheet parameter will simply be called sprite sheet. And we'll make our call to the base constructor passing along sprite sheet. Now inside of this constructor we have several things that need to be addressed. We need to do some basic setup for the enemy itself, and a lot of this involves leveraging the configuration values, things like health and other behavior settings. We're also going to set up how the explosion sprite sheet looks. Then we need to set up our enemy's weapon and set up the fire timer that calls that weapon. So let's begin with some of the parameters. Let's set our health value equal to the value given in configuration for enemy health. And we'll also set up the explosion sprite sheet. We'll simply reuse the current small explosion sprite sheet, just because that is the main explosion available to us as the graphics we have on hand. Alright, moving on from here, we need to set up the weapon system. Now before we even address the actual weapon itself, we also need to set up a fire action for that weapon to use. And this enemy interceptor, being a ship, because of course remember enemy extends ship, that means we have a fire action field. So we'll store a fire action in that field, and that fire action will be a new instance of the fire action delegate, and we're going to encapsulate, or rather we need a method to encapsulate for this delegate. To begin with, we're actually going to use the player's bullet fire method. Of course, we'll find that this is less than convenient for an enemy, as this allows the enemy to destroy itself. But at the moment, we have no other bullet firing code, so we'll drop this in for the time being. We'll grab this method from projectile bullet, and the method name is, of course, fire bullet. Now we can address the weapon itself. We'll look at our weapon field, and we'll instantiate a new weapon burst. Then to set up the weapon burst, we need the ship, so we'll reference ourselves in that. The fire interval will be given by configuration as enemy fire interval. Let's see, enemy
burst fire interval.
It's a good point. Burst fire interval, because we can look at this as the, you could say, the inner interval.
Yeah.
The burst fire interval goes along with the burst weapon.
Exactly.
And then one final thing
So
is...
let's go ahead and change total there.
Yeah, that's based on the configuration.
Okay, I see.
And one final thing is we do need the... Is it the interval? I guess it's interval then total. We're looking at the... yeah. The parameters were simply swapped. I was jumping ahead one parameter and getting onto total. So if we drop in a comma, that fixes that.
Whew, and I thought I was going crazy for a minute.
But burst enemy, that's burst fire interval. That's the enemy.
Yeah, I think it's enemy burst.
And that wraps up the call to the constructor. Alright, now that we have the weapon itself set up, there are a few things left, because if you remember, weapon has defaults for direction and offset. Now these offsets are useful when applied to a player which shoots upscreen, not very useful to an enemy that generally shoots downscreen. So we're going to set up these parameters ourselves. So we're going to look at our weapon and set up the direction to be equal to a new vector 2, which points downscreen. So 0 in X, 1 in Y. Then we're also going to set up a more useful offset for the weapon, because if you remember, the default offset for a weapon is to be on the top of any given sprite. And we want this to come, the projectiles are, or excuse me, the enemy is oriented in the opposite direction, it points down. So we need to set up the offset to be equal to the bottom of the sprite. So that will be a new vector 2, where we give a value of 0 in X, so we stay centered on the sprite in question, and then we'll simply plug in the sprite's origin in Y. And that should take care of orienting and positioning our weapon. Alright, one last thing that's needed here is we need to set up our timer. So the fire timer will be instantiated here as a new timer. Then we'll turn around and subscribe to the fire event. So this .firetimer.fire. I'll hit tab to let it drop in a new notify handler, and then tab again to accept the name given, and now we have an event handler for fire timer. Then one last thing I'll do is we'll make sure that the fire timer gets kicked off so that it begins running. So we'll say this fire timer, and we'll tell it to start. Alright, and inside of start is going to require a double, and we'll specify that from the configuration of config.enemy fire interval. This again being the longer fire interval to control the overall cycle of firing. Alright, moving into the fire timer, this is the code that gets called whenever our enemy needs to fire. Now there's actually a few things to take into account, because there are several things that could cause the enemy to be unable to fire. These include things such as the enemy being dead, or the enemy not having a target, or the enemy being past the player on screen. We don't want the enemy to try to shoot through itself to hit the player that it has already gone past. So we're going to do a series of checks, and only if we make it through all checks are we going to proceed with firing. The first check is, of course, to see whether or not the enemy is still alive. So if we'll just make an if statement, if this .dead, then we will simply return. I will also note here, the way I'm going to perform the series of checks is to set up a scenario where anytime we reach an undesirable result, we simply return out of the overall method. Now, if this is slightly against the idea of purely structured programming, where one would continue to nest if statements instead of jumping out using a return. Now, this just comes down to personal coding preference. Since this is a list of checks, I personally prefer to read that as a linear series of checks. If you wish, there would be no reason not to put these into nested if statements. Alright, the next thing we need to do is to check whether or not we've got a target. But before we have a target, we need to, at some point, pick a target. We need to target some node. Now, the node that enemies are going to need to target will be a player, because enemies will shoot at players. Now, the end goal is to have our enemy class randomly pick a player to shoot at. Since we do not yet have random node picking functionality available to us, we are going to temporarily hardcode this in such that our enemy selects player 0 to fire at. Once we have the enemy class up and running, we'll switch this out for some more robust behavior that involves picking random nodes. Now, to set up a scenario where we grab ship 0, we do actually have to make sure that ship 0 exists, because there is the possibility that all player ships have been destroyed and there's no player ships to shoot at. So we'll set up an if statement that will possibly result in target being null. The check here is to see if playerships.playerships.count is greater than 0. If our count is greater than 0, that means we have a player ship somewhere. If that's the case, we'll set our target equal to playerships sub 0. Again, we'll just hardcode this in for player 0 for the time being. If we were unable to grab a player ship, we'll make sure that we set our target equal to null to indicate that we do not have a target. After that, we'll jump down and we'll do a check, and we'll see if the target is, in fact, null. Then we've reached a state where we're not going to fire. If we have no target to shoot at, we're not going to fire anything. So we will return. Now you might be looking at this wondering, saying, why did we set target to null and then do a check on that thing that we had just set? Why not put this return directly under the else? The reason is here is, once again, this entire block can be viewed as temporary code, because this whole if-else statement is going to be replaced by a random player ship selection call. Now that we've determined that we do in fact have a target, we're going to aim our weapon at that target. After we do that, we're going to check that resulting aim vector and see whether or not we're aiming upscreen. If we're aiming upscreen, that means we've already passed the player ship, and we want to cancel firing because we're going to consider the player ship out of range. But of course, before we get that directional vector, we need to set up our weapon's direction. So this, again, this is the point at which we're aiming our weapon at the player. So we'll say this.weapon.direction is equal to the value of vector2.normalize. Basically what we're going to do is take into account the target's position, subtract from that our weapon's position. That will get a vector measuring the distance between the two, but we're going to normalize that to a unit vector so that we can use that simply for direction. So the value that we're going to be normalizing is target.position minus this.weapon.position. You'll note that we're using our weapon's position instead of our own position in this case. The reason being is that the weapon is actually a little bit offset from our own position, and we want to take into account that weapon offset for aiming. Otherwise, we'd be shooting towards the bottom of the ship graphic instead of directly at the center of the ship graphic. So this will return a vector2. The call to vector2.normalize will normalize that vector and store it in direction. And let's see. Jumping down now that we have the aim vector, we'll do a check on that vector. So if this .weapon.direction, and we're going to be looking at the direction's y value to see if it is less than or equal to 0. Again, if we're looking at a y value of negative, negative is looking upscreen. So basically, if we're completely horizontal or looking upscreen, then that means that the enemy is either level with us or upscreen from us, and we'll consider it out of range and we'll cancel firing. So we'll simply return. And if we've made it through all of these series of checks, then we are in fact ready to fire. So we'll call upon our weapon, and we'll tell it to start fire. Alright, moving on from here, we need to make sure that we do a little bit of cleanup inside of remove. So I'm going to override the remove method. And inside of here, we're going to make sure that we stop the timer, because if this enemy is ever destroyed or goes off screen or is no longer considered relevant, we want to make sure that that internal timer is removed from the timers list. So we're going to call upon the fire timer, and we're going to tell it to stop. And now that we have all this stuff in place, there is a bit of code left for enemy, because we of course still need the avoiding behavior, and we need to set up a specific projectile for use with the enemy. But with this code that we have in place already, that is our initial setup inside of the constructor and our firing behavior, we should actually be able to try things out. I'm going to build first to make sure that there are no errors inside of the Enemy Interceptor class itself. Then I'm going to jump down to Game 1, and we're going to, for the time being, comment out our asteroid creation code, and we're going to spawn an enemy. I'm going to copy the lines of code that are necessary for spawning asteroids, and I'll simply adjust them a bit for spawning enemies. Also, I will comment out the loop that spawns asteroids so we can focus on the enemy itself. I'm going to change the variables type over to Enemy Interceptor. Then we're going to call the variable enemy and spawn new enemy interceptors. As we spawn these, we're going to feed in the sprite sheet for enemies. That is the enemy sprite sheet. I'm also going to grab this enemy variable name and replace all the other variable names. When we position it, I'm going to position it centered on the screen. We'll give a value of screen width divided by 2, and we can leave it spawning off screen in Y. For a speed value, I'll simply set this to a value of 2, and we can leave the direction as running down screen. So, now if we run the game, we can see that an enemy spawns, runs down screen, and fires at us.
Very nice.
And you'll notice right at the very end there, he managed to destroy himself. Let's take a closer look at that. If I quickly move out of the way, we'll note that as he's firing, he's actually hitting himself with the projectiles. Reason being is he's firing ship projectiles. You also notice that the projectiles went through us as a player ship. So the enemy needs his own special kind of projectile that, 1, destroys us, and 2, doesn't destroy him. Though it is interesting to see that the weapon and fire action system has held up such that we can easily apply it to an enemy. We just need to tweak it a bit, and then it will work properly for an enemy. So this is going to involve writing a custom fire action for this enemy. And we're actually going to write that fire action directly in the Enemy Interceptor class.
Yeah, I mean, you could begin the creation of new classes that are of enemy projectile types if you'd like. Once again, the primary focus of Space Fighter is really the engine and getting some elements interacting with one another within the engine. And we've made quite a robust weapon system at this point. So I don't see anything wrong with, since this is more of a proof of concept, instead of us really hammering down some sort of incredible enemy for Space Fighter, with putting fire action into enemy itself.
Exactly, and one thing that we pointed out is the key thing to any fire action is its method signature over where it appears anywhere in code. It can appear, you can set up the class structure however you like.
And that does really bring us back to just how cool the weapon system is, because as far as the projectile part goes, it's really just a fire action from the ship itself, and we can put any functionality into the fire action.
Now, in this specific case with the Enemy Interceptor, we are actually going to leverage a little bit of an advantage by being able to put the fire action into the enemy itself. Whereas in the past we had made the fire action static when it was inside of the bullet projectile, here inside of Enemy Interceptor we're actually going to make it an instance method. We'll see why in just a second. We'll make a method, void return type, that is called fire bullet. Then we're going to set up the necessary method signature for a fire action. That is going to be a vector2 for direction and a vector2 for position. Now, as we're firing bullets, there's one thing to point out, and you might have noticed this if you were watching really close when we were testing earlier, and that is when the enemy destroyed itself, it only took a couple projectile hits to destroy itself, and then 2 more projectiles spawned out of nowhere where the enemy had been. The reason being is that there is not a call into a burst weapon to cause it to interrupt its sequence, so that means that it will finish its sequence no matter what. And we can easily combat that inside of the fire action by simply checking to see if the enemy is dead or not before we allow projectiles to be spawned. Because this code is called individually every single time the burst fire weapon goes through its queue item by item. So it's here that we have the projectile by projectile granularity necessary to allow some projectiles to spawn and others to not. So that way, if you destroy an enemy as it's firing, the visual effect is that the firing sequence is interrupted. So the check here is if we're not dead, allow projectiles to spawn. So if not this dot dead, then we will proceed with instantiating a bullet, setting up the bullet's parameters, and then sending it on its way. I'll make a variable of type projectile. It could be bullet. The reason I'm using projectile is I believe all of the fields that we're going to set are general in the sense that they all belong to projectile, even though we're going to instantiate a projectile bullet. So the variable name is bullet, and we are going to instantiate a new projectile bullet into it, giving the sprite sheet found in the configuration value of config.enemy bullet, and give it enemy bullet sheet. The next one we'll need to do is set up the collision list that the bullet is aware of. So the bullet's collision list is going to be the list of players. So that's playership.playerships. Moving on from here, we need to set up the position and direction. So the bullet's position will be set to the incoming position parameter. The bullet's direction will be set to the incoming direction parameter. The speed will be given by the config value enemy bullet speed. Looking into config, we have enemy bullet speed. The bullet's damage value will be given by config.enemy bullet damage. And the bullet's explosion sprite sheet will be the general projectile explosion value. That is config.projectile explosion. And with all of those lines for setup now in place, we should be able to go up and change our fire action to look at the internal firebullet method, that is this $firebullet instead of projectile bullet.firebullet. So if we build, everything has succeeded, we can run, and now the enemy will fire enemy bullets. You'll notice that those enemy bullets do not damage the player himself, it damages the ship.
Very nice.
So looking down here, we now need to address the random player targeting. And to show, first let's show the problem. Whenever we spawn 2 players, he's only going to shoot at player 0. Before we show this, let's give the enemy more on-screen time. I'm going to go over to game 1, and we'll set his speed to a value of 0.2. Now if we run the game, we have our enemy spawning up at the top of the screen, but he moves in very slowly. Now if I spawn a second player in and move him over, and move the players side by side, you'll note that the enemy is always going to shoot at player 1. And of course, that's showing the fact that he's just using player 0.
Which makes sense, yeah, since we hard-coded that in.
Now, to get the functionality where the enemy is able to pick random players, we could code in a solution directly in Enemy Interceptor, but since the code could be considered general use, the way we're going to approach this is we're going to add some functionality to GameNode, and that functionality is going to allow us to pick a random game node out of any list of game nodes. And this is convenient because we have a few lists of game nodes and things such as player ships, or enemies, or projectiles. So we're going to go into the game node class, and we're going to set up a system which will allow us to grab random items out of a list. We're going to begin with a static field of a instance of the random object. So we'll have a static field of type random called random, and that will be a new instance of random. Then we're going to go down to the bottom of game node and we'll make the method itself. The method will also be static, again, just because this is not meant to be applied to any specific game node. It's just some functionality floating around that is allowed to grab general lists and give us nodes. The method itself is going to be public. It will be static. It will return a game node, and the method name is pickRandomNode. PickRandomNode is going to take in the list from which you wish to pick. So this is going to be a list of game node, and we'll call this parameter target list. Inside the method, we're going to do a check. First, we're going to see if there are any items to get out of that list, meaning if we try to run this method on an empty list, we'll simply return null. So the if statement will do a check and see if the target list's count is greater than 0. If so, we can pick something. If not, we'll just return 0. So I would drop in the else, but auto-formatting would get a little bit unhappy with the fact that we stacked if, else, and no statement. If we do in fact have an amount of items, we will return one of the random items inside that list. So we'll return from the target list element sub, and then we'll pick out an element. Now we'll pick that element using a call to random. We'll say random.next, and then we'll specify a max for the call to next. And that maximum value is going to be the value of target list.count. Now take note of the tooltip here, reminding us of the fact that it is a what was the one? Let me grab one more, because what I want to show is the fact that this call to next, I see. It's target next dot count. I was trying to get it to show the fact that max value is exclusive. That means that count, let's say we have a list with 3 items in it, count is going to be 3, but this being exclusive means our range is 0, 1, and 2, and all of those values are within range on a list with 3 total elements in it. So we'll finish off our call here. Now, if we did not have any items to return, we'll simply return null. And that will take care of the method by which we pick random nodes. Now back in the Enemy Interceptor, we can replace the original if block, which grabbed our target, and we can simply replace that to a call to this.target being equal to game node dot pick random node, and the list we wish to pick from is from the players list. So we'll give playership dot playerships. That will pull out a random ship out of that list, set it as the target, and now this subsequent if statement makes more sense, because there's the possibility that pick random node return null if there were no ships, and if there were no ships we'll return and we won't bother initiating a firing sequence. Now let's build, test. We'll drop in the second player, move the players out to the side a little bit, and we'll watch the firing sequences. And now we can see that the enemy is picking randomly between the two.
Very nice.
Alright, this should bring us to our final topic, and that is enemy target avoidance. So what happens when the enemy gets close enough to the ship that makes him want to go around it? In order to set this up, we're going to override the update method so we can make adjustments to our direction on a tick-by-tick basis. So we will override the update method, and we'll begin with our first check. The first thing to do is we can't avoid a target if we don't know what it is, so we're going to only avoid targets if target is not null. So if this.target is not equal to null, then we can run avoidance procedures, and if not, we'll simply skip and run as normal. Now the next check we need to do is we only avoid the target if we're within the enemy avoidance radius. So we need to do a check. We need to determine the distance from ourselves as an enemy to the target ship. So we'll do a check and say if vector2.distance between our position, the enemy, so this dot position, and our target's position, this dot target dot position. If that value is less than the enemy avoidance radius, we'll look into config and get the enemy avoidance radius value. If it is in fact within that radius, then we can proceed with some avoidance calculations. To calculate the vector that we should use in direction while avoiding, I'm going to make two other vector variables just to make the operation easier to describe. We're going to drop down a vector named down to represent the downscreen direction. Then we're going to make another vector called away from target to represent the vector which would take us directly away from the target. The first, a vector2, will be called down, and that's very easy to describe. That's just hard-coded in as a vector2 going 0 in x, 1 in y, again, moving down screen. The second vector is going to be called away from target, and that value will be calculated by subtracting the target's position from our own position. And in that way we'll get a vector which would represent the amount of the movement necessary to go from player to enemy, so basically a vector pointing from player to enemy. Then if we normalize that vector, we'll have a unit vector pointing away. So to drop this in, let's first set up the call to vector2.normalize, and the value to normalize will be our position as an enemy minus the target's position. So this dot target dot position. Alright, now that we have two vectors, we need to decide exactly what our resulting direction is going to be. And to do this, we'll interpolate between the down direction and the away from target direction based on what our enemy avoidance weight is set to. So that means our direction will be equal to the value of the linear interpolation. We'll look into vector2 to grab the interpolation functionality. We will interpolate between the down direction and the away from target direction. And we're going to interpolate based on config.enemy avoidance weight. So to show what's going to happen, since we know that this value is set to 0.3, a value of 0 would take the down direction 100%, a value of 1 would take the away from target position 100%, so 0.3 will simply be more down than away. That way we maintain a generally downscreen direction as we move around the target. Now after we have acquired this new vector, I have to keep in mind that the resulting interpolation may not be a unit vector, so we are going to normalize that result so that we maintain the behavior of a unit vector within direction. So say this dot direction dot normalize. Alright, one final thing to do is to make sure that if we have been avoiding, meaning we've been adjusting our direction to avoid, but have since gone outside of the enemy avoidance radius, we need to resume a downscreen direction. So basically saying that if this if statement represented being within the enemy avoidance radius, then an else statement would give us the code necessary for when we're outside of that radius. And in that case, we'll set our direction to be downscreen. So this dot direction will be equal to a new vector2 pointing down screen. And with that, we still have our call to base.update. So we should be ready to build and try things out. So, as a matter of fact, I'm going to speed the enemy back up because it's going to take him a little while to reach us at that speed. We'll set the speed back up to a value of 2, and then watch as he gets close to us, avoids us, and continues off screen. I will note one thing, that this is a rather rudimentary behavior, and that if we stay centered on the enemy, he'll simply slam directly into us. And that's because we're taking an interpolation of upscreen versus downscreen, and then favoring downscreen, then renormalizing so we maintain our continuous speed. But with that, I believe that has all of our enemy behavior set in place. Again, there were several things to consider, and that was enemy, or rather weapon setup for the enemy, where we had an actual weapon as a burst weapon to control firing, and then a timer to control pressing the trigger on that weapon. Then we addressed several considerations on whether or not the enemy should actually fire, and then wrapped everything up with some code to allow our enemy to avoid the player's ship.
Excellent. All right. Well, with that, that is going to bring this video to a close. Thanks a lot.